My name is Hadassah Balkorda, and my research is on the importance of phytoplankton in ocean food webs and climate. I was really excited to have this topic. The overview of this research is that phytoplankton are small plant-like organisms that are the foundation for the ocean's vast food webs and play a vital role in regulating the Earth's climate. They do this through producing energy for marine life. This production of energy is very important because phytoplankton sustain ocean life and regulate Earth's climate. But unfortunately, climate change is disrupting their balance and impacting marine ecosystems worldwide. Without these small organisms sustaining ocean life, everything falls apart, for they support everything from zooplankton to larger marine animals. My hope is that through this presentation, people following along will be able to gain an understanding of the role and importance of phytoplankton. The audience will learn that phytoplankton are essential for ocean life and climate change can disrupt them. Key terms that are essential to this research are phytoplankton, algal blooms, marine food webs, and climate change. Oops. Some background information or context is that phytoplankton have been recognized as the foundation of marine ecosystems, contributing to about half of the global primary production and supporting entire food webs. This is amazing because they only account for less than 1% of the biosynthetic biomass on Earth. Research shows that as climate change alters ocean temperature, light, and nutrient cycles, this results in phytoplankton populations having shifts in timing, size structure, and regional abundance. These changes also affect the frequency and intensity of harmful algal blooms, making future patterns difficult to predict. To go into greater depth of the key terms and what they mean, I will define them. Phytoplankton are a teeny plant-like organism in the ocean that make oxygen and form the base of the marine food web. Algal blooms are a fast growth of algae in the water that can sometimes be harmful. The marine food web is the system of who eats who in the ocean. Climate change is the long-term changes in the Earth's climate. My areas of focus. The vastness and complexity of phytoplankton and its relationship with marine ecosystem cannot be neatly put in a box, but the main areas of focus for this research are the importance of phytoplankton in marine ecosystems, the effects of climate change on phytoplankton populations, and harmful algal blooms and the predictive challenges that go with them. Phytoplankton produces about half of the global primary production and forms the base of marine food webs. Their productivity drives chemical cycles that supports biodiversity, especially in regions like the Southern Ocean. Effects on climate change on phytoplankton communities. Warming, changes in lighting condition, and shifting nutrient availability affect phytoplankton growth, timing, and distribution. Climate change impacts differ based on cell size, and food web structure, leading to shifts in which species dominate the food chain. What this means is that smaller phytoplankton thrive in nutrient-poor waters, while larger ones are the opposite. Large phytoplankton feed on large animals, while teeny ones feed on microbes. This ultimately affects larger animals like fish and whales. Harmful algal blooms and predictive challenges. Climate-driven changes in ocean conditions can increase the likelihood or intensity of harmful algal blooms. Predicting future harmful algal bloom patterns is difficult due to complex interactions among climate, nutrients, and species traits. The research findings were that phytoplankton are central to global productivity and marine ecosystems. Evidence that supports this is that phytoplankton contribute about 50% of global primary production and serve as the foundational energy source for marine food webs. They drive key biogeochemical processes such as nutrient and carbon cycling, making them essential for ecosystem functioning. The phytoplankton do this by absorbing dissolved nutrients from the water and converting those inorganic nutrients into organic biomass. This is important because when other organisms consume phytoplankton, they receive the nutrients they need. Climate change is altering phytoplankton growth and timing. Evidence supports Evidence that supports these changes in temperature, light availability, and nutrient supply shift when and how phytoplankton grow, affecting seasonal bloom patterns. Warmer waters speed up phytoplankton metabolism, meaning faster growth and a larger nutrient demand. More light, due to numerous factors such as seasons changing or cloud cover, can cause blooms to appear earlier than normal, which can also affect growth. Research shows that warming can advance or delay bloom timing, affecting predator and prey interactions in marine food webs. Along with this, increasing water temperatures strengthen water column stratification. Oh, some more research. Um, oh, nope, that was the right page. Um, Along with this, increasing water temperatures strengthens water column stratification, which alters nutrient distribution and impacts phytoplankton production and cell size. Some more research findings are that climate change influences harmful algal blooms, but predicting this is difficult. Evidence that supports this is the warmer temperatures, altered ocean conditions, and changing nutrient inputs can increase the likelihood or severity of harmful algal bloom events. Long-term fossil records of dinoflagellate cysts show historical links between climate change and harmful algal bloom occurrence. Yet predicting future patterns is challenging due to the complex species-environment interactions. This can look like algae species growing in well and warm water, but if it does not get enough nutrients for whatever reason, it may not bloom, showing how much it can vary. So how does this relate to oceanography and meteorology? It relates because this research topic relates to marine ecosystems, which rely on the balance of all living marine organisms, an important concept we learned about this year. Phytoplankton are primary producers and are essential to marine life. They are the building blocks to the greater ocean food chain at large. Are there any conflicting viewpoints? The only conflicting viewpoints I found were in the bloom timing variability for phytoplankton blooms. Some research suggests that warming temperatures could either make phytoplankton bloom early or delayed. This was not so much conflict, though, more so just showing the variability of the blooms. Real-world applications. If the phytoplankton population changes in any way, it could alter the food web, leading to a decrease in the marine animal biodiversity. This in turn affects systems like the fishing industry that humans rely on for job stability and food. Without phytoplankton, there's a good chance a lot of coastal areas will go without seafood and markets that they thrive off of. To conclude, phytoplankton form the foundation of marine ecosystems, supporting the food webs and driving global productivity. Changes in their growth and distribution due to climate change can affect biodiversity and the occurrence of harmful algal blooms. Studying these organisms connects oceanography and meteorology. The future research could help improve predictions and guide conservation efforts. So, with all that being said, please appreciate these little marine friends because they play a larger part in the ocean in your world than you think. And I also provided a photo of the food cycle in the ocean, the marine food web, and I thought it highlighted how phytoplankton are the basis of all of that. Okay. The sources that I used were compiled over the semester and consist of peer-reviewed articles and writings from UMair's 8 Oceans Across Boundaries 2017 conference. The peer-reviewed articles that I used for this research were the Frontiers in Marine Science, Journal of Phycology, Marine Biology, and Hydrobiologia. I also have my photos that I used to cite here as well. Thank you so much for listening.